boys and girls, it's Mrs. Leffler here, and today we're going to be learning about absolute dating. It's often called radioactive dating or radiometric dating. Today we're going to be talking kind of about carbon dating, and we're going to model it here with these M&Ms. If you were in class, you'd be using these M&Ms or maybe some Twizzlers to show Half-Life and how we do absolute dating. But for now, I'll be the one having the snack. So anyways, so I've got this plate here, and these M&Ms are representing carbon-14. And carbon-14 is an isotope, which is radioactive. It means that it's not stable. It's giving stuff off. And it's not anything to be alarmed about. Carbon-14 is all around in our atmosphere. And so when we breathe in carbon dioxide, we take in carbon-14. And when we eat food with carbon in it, then we ingest carbon-14. So we have trace amounts of it in our body. But once an animal or a plant dies, it's no longer eating or breathing and taking in any more carbon-14. So those molecules, or atoms rather, inside of that animal are going to decay. And when they give off the radioactive and they decay, they form nitrogen-14. So this is the parent isotope, and it's going to be replaced by the daughter isotope, which is stable. Okay, so we've learned a little bit as you've gone on watching different videos and reading different things. But here's an example. We have 20 carbon-14s here. So this is a fossil that we just found, and it just died. So it can no longer take in any more carbon-14. So this is the maximum amount that it's going to have. And if we were to wait a certain amount of time, half of these carbon-14s would be replaced by these nitrogen-14s. So we call that a half-life. And for carbon-14, the half-life is 5,700 years. So we're going to go ahead and do that. We're going to pretend that we've had a half-life. I'm going to replace these carbon-14s with nitrogen. Okay, so you can see here that half of them, if we were to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, are still carbon-14. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are nitrogen-14, or the daughter isotope. So we've had one half-life because 50% or 1/2 of the original carbon-14 are left. So we would know if we found this fossil that it was about 5,700 years old. Okay, now what happens if it has another half-life? Well, there are 10 carbon-14 atoms here. So if we took half of that, that would only be 5 this time. So we could replace 5 of those. And we would end up with 5 carbon-14 and 15 nitrogen-14. So we only have 5. We started out with 20. So 5 out of 20 is 1/4 or 25% of the original. So if we have 25% of the original carbon-14, then we know we've had 2 half-lives. And 2 half-lives, if the half-life is 5,700, then it's going to be 11,400 years old. Now we could do that again, but I'd probably have to bite one of these M&Ms in half to get another half-life, and we'd end up with 2.5 left, which would be 1/8, and so on and so forth. So I hope this M&M demonstration has helped you to understand half-lives and radioactive dating.